Hi everyone, welcome to the second session of the types of reagents and reactive intermediates. Myself Sumalata S, Assistant Professor from the Department of Chemistry, SKNG GFG College, Gangavati. In this session, we are going to discussing about the carbanions, definitions and examples, types of carbanion, methods of formation of the carbanion, reactivity of carbanion, and finally stability of the carbon ions. Let's begin the session. Carbanions. What are these carbanions? The word itself indicating the carbon anions means carbon atom bearing the negative charge. A carbon ion is one of the several reactive intermediates in organic chemistry. A carbon ions are the species with an unshared pair of electrons and a negative charge on the central carbon atom. As we discussed in last session, the carbocations, these are bearing the carbon atom bearing the positive charge, and these are electron deficient species. Whereas here the carbon atom consisting of the unshared pair of electrons, due to this there is a negative charge on the central carbon atom. These are termed as a carbon ions, and these are formed by the heterolytic fission of a covalent bond. Next, types of carbon ions. As we discussed in case of carbocations, similarly the carbon ions are also classified into three types as a primary carbanions, secondary carbanions, and tertiary carbanions, according as the negative charge is present on a primary, secondary, and tertiary carbon atom. Next, coming to the structure of carbon ions. The carbon atom is sp3. The carbon atom of carbon ion is sp3 hybridized. Out of the 4 sp3 hybrid orbitals, the 3 hybrid orbitals are involved in the formation of sigma bond with the 3 other groups, whereas the 4th hybrid orbital is consisting of the unshared pair of electrons. Therefore, the geometry of the carbon ion will be pyramidal, similar to the ammonia. As in case of ammonia, this is forming the 3 sigma bond with the 3 other hydrogens, and this is consisting of a unshared pair of electrons on the nitrogen atom. Hence, this is having the pyramidal like structure. Similarly, as this ammonia, the carbon ions are also having the pyramidal structure. Next, generation of the carbon ions. How these carbon ions are formed in the chemical reaction. First method is the proton obstruction by the base. When bases like OH minus is reacting with the compounds which consisting of the beta hydrogens, these will going to obstruct the hydrogen H plus ions or the proton from the beta carbon atom, and these are get eliminated as the water molecule, and the resulting compound is having the negative charge on the carbon atom. Hence, the carbon ions are formed by this process. Second method is the by decarboxylation. What is the mean by decarboxylation? The reaction in which the carbon dioxide is eliminated. Then that reaction termed as a decarboxylation. Here the carboxylate ion, how it is formed? It is formed from the carboxylic acid, that is RCOOH. This is when loses a proton H plus ion. This is gets converted into RCOO minus. This RCOO minus is by the elimination of carbon dioxide, carbon ions are formed. Next, third method is by organometallic compounds. What are these organometallic compounds? Means here the alkyl group or the carbon atom is directly attached to the metals. Organometallic compounds are those compounds in which the carbon atom is directly bounded to the metal atom. The partial negative charge on the carbon bonded to a highly active metal results in greater reactivity, that is referred to as a nucleophilic or carbon ion character. For example, when the alkyl bromides react with the magnesium in the presence of dry ethyl ether to form the alkyl magnesium bromides or alkyl magnesium halides are formed. This is called as the Grignard reagent. Here the alkyl group which is directly bounded to the metals. Hence, this is having the metals are highly reactive or active in nature. So, this is undergo reaction and we will get the carbon ions. Okay. Next, coming to the next topic, stability of the carbon ions. How these carbon ions are stabilized? First one is by inductive effect. If positive inductive effect group attached to the anionic carbon, then it decreases the stability. What happens in case of carbocations? The alkyl groups, if the number of alkyl groups increases, the stability of the carbocation goes on increases. But here, if the alkyl group or the positive inductive group increases, the stability goes on decreases, because it increases the electron density on the anionic carbon. If minus I effect group attached to the anionic carbon, then it increases its stability because it decreases the electron density on the anionic group. Positive inductive effect means the groups which are electron releasing in nature. The negative inductive effect group means the groups which are attracting the electrons or withdrawing the electrons. The stability of the carbon ions is given by the methyl carbon ion is more stable than the primary carbon ion, is more stable than the secondary carbon ion. This is in turn more stable than the tertiary carbon ions. Second one is by resonance. Carbon ions are stabilized by resonance. More the number of resonating structures, more will be the stability of the carbon ion. Here in case of allyl, this is the allyl carbon ions. Allyl means the carbon atom which is attached to the carbon atom involving the double bond. So here what happens, there is a delocalization of this negative charge takes place and this can be stabilized. Similarly in case of benzyl carbon ions, means the carbon atom having the negative charge is attached to the benzene ring, then that is termed as a benzyl carbon ion. Here also this negative charge is undergoing delocalization and this can be stabilized. Next, coming to the reactions of the carbon ions. Now let's explore the how these carbon ions are undergo reaction with the other reagents. Carbon ions are most often short-lived transient species and react further without being isolated. The first reaction is the reactions with the positive species are the electrophiles. Due to this, carbon ions is having the unshared pair of electrons. These are acting as electron rich centers are the nucleophiles. These when reacting with the electrophiles and there is a transfer of these electrons towards the positive species and there is a formation of the covalent bond and the compounds are formed. Second one is the reactions involving the displacement of an atom or a group. For example, when carbon ions is reacting with the alkyl halides, what happens? This R minus will go and attacks to the central carbon atom of the alkyl halides and it gets eliminated the allied ion, that is X minus is eliminated. Okay, X minus is eliminated and we will getting the hydrocarbons. Okay, this is the SN2 reaction, means nucleophilic bimolecular nucleophilic substitution reaction. Okay, next, by this session we will come to know that the carbon ions, what are the carbon ions, how these carbon ions are formed, types of the carbon ions, structure of the carbon ions, stability of the carbon ions, and finally reactivity of the carbon ions. Thank you for watching.